All right, so welcome to the first video on chapter 2. So periodically I'm going to step away and let you copy the notes down, which I recommend you do. So pause it, copy the notes down, and then press play, and I'll start chuntering off. All right, so in chapter 2, we're all about sort of exploratory data analysis, EDA. And exploratory data analysis is basically when we are confronted with a new data set, what we should do to sort of muck around in that data set to get an understanding of what the data is and what it's telling us. And things like how many, are there a whole bunch of outliers? Is it really clumped together? So just sort of getting a general sense of what the data looks like, okay? So EDA, exploratory data analysis, is an approach to examining and describing data to gain insight, discover structure, and detect anomalies and outliers, okay? Now, one of the terms we'll be using is our data will be arranged via variables that we're interested in. And one type of variable is a categorical variable. And a categorical variable is a variable that places observations into groups. So, for example, a categorical variable could be carrier, and that's to denote airline carrier, okay? Just trying to make sure there's not too much glare there. So, doesn't seem to help much. Okay, so I might have a data set about flight delays, and the flights are organized. One way you could organize the flights is by which carrier it is. Is it Delta? Is it United? So in a categorical variable carrier, it might place data into two groups. So I might have some flights from United Airlines. I designate those as UA under the carrier variable, and others are denoted for American Airlines, which will be AA under the carrier variable. And these categorical variables are also called factor variables, okay? And we can use factor variables to make bar charts and contingency tables to summarize the counts under these categorical variables in various ways. And I'll do an example on R in a minute, okay? All right, let me wheel us over and show you a bar chart. All right, so again, pause, copy, and then press play. So one of the main kind of charts we're going to use with categorical variables or factor variables is called a histogram. And that's a bar chart in which the height of the bar is corresponding to the number of data items that fall within the specified range of that variable, okay? And I could use it with categorical variables. I could also use it with variables that are more numerical value. Like there could be a variable for heights of male students at St. Thomas. And the values of that variable would be the height in inches of all the male students. So it could be numerical data as well, okay? So here's an example of a histogram. I have a variable X that's numerical in nature. So apparently there's values from 0 to 500 that are recorded. And I'm just going to group them into categories, the 0 to 100 category, the 100 to 200, et cetera. And the height of each category tells me how many entries there are within that zone. So there's about, I don't know, maybe 17,000 entries that have an X value that's between 0 and 100. And there's more data items that have an X value between 100 and 200, et cetera, et cetera. And if we see that after the peak, we have a long tail to the right, we would call that right skewed. If we have a longer tail to the left than we did to the right, we call that left skewed. So when I say skewed, it means in which side is the longer tail, okay? Now, when I don't have a whole lot of counts in my data, I might do a dot plot instead of a bar chart, where the dots denote the number of entries or the number of items that fall within this count. So in this data set, it looks like I have 1, 2, 3, 4, 5 pieces of data that have an X value between 0 and 100, 4 pieces of data that have an X value between 100 and 200, and 2 pieces of data that have an X value between 300 and 400. I don't know what happened to 200 and 300, but apparently they're 0. Okay. All right. So at this stage, I'm going to flip over and look at some R commands for how to create some of these bar charts, histograms, and contingency tables. Now, I warn you, for some reason, the audio starts to get a little bit broken up when I do a screen share, but hopefully it's going to be clear enough, okay? So what you should be doing is you should open up the R file for chapter 2 and exercise 2-5 that's found on Canvas under files and under, I think it's R files, the folder R files within the files module on our Canvas course site. Okay. So if you open up that R file, you should see something similar to mine, okay? And the first thing we always have to do, and I always forget this, the first thing we always have to do is to make sure under packages on the bottom right quadrant, we need to scroll down and make sure that we click the resample data packages, okay? Because then when we refer to a file, a data file from the resample files of data, R will know what we're talking about. So it'll import the correct data set. Okay. All right. So I've got the resample thing clicked. And now I'm going to go to the top left. And this is where we type in our commands. Right. Now what I'm going to do is I'm going to go all the way down to the end. And I'm going to look at exercise 2.5. Okay. Now, in exercise 2.5, we've got something, a file called GSS 2002, which is basically just a general survey of opinions of people. And if I use the view command with capital V, I'm just looking to get this thing out of here. If I use the view command with a capital V, and if I click on the run, we're going to see what that data set looks like. Okay, so as an Excel file, it looks like that. And you'll note that there's a whole bunch of data, and each of the columns is a separate variable. So I have an education variable, I have a marital status variable, a religion variable, et cetera, et cetera. And I'm going to be looking at a couple in particular. So maybe we're going to have something about owning guns. Let's say I'm focused on that issue. Who owns guns, who doesn't? And you note that some data entries have a no, so that person reported they did not own a gun. Some have yes, so that person reported they did own a gun. And some people chose not to answer that question, so that would be an NA. Okay. All right, so let me click back to my R file. So the file I'm looking at right now is basically an Excel file. Okay. I'm going to click back to my command module here. And I'm going to do part A of exercise 2.5, which is to make a table indicating people's opinion on death penalty. Okay, so I've got table. I'm referring to the file GSS 2002. And what I want is $. I want a table describing the death penalty opinions in the data set. So I'm going to run the command. And down here on the bottom left, you see that 899 people favor the death penalty and 409 people opposed. So that was the table command. And then if I go back up, I can run the bar plot command on that table command. And that should create in the bottom right a bar plot, which tells me the exact same information in more of a graphical form. Okay. I can do a similar table command for owning guns. So it looks like I've got 605 people who say they don't own guns, 9 people who refuse to answer, and 310 people who said they do own a gun. And then under the summary command, if I run that one, I get a very similar table. Okay. And in the summary command, I also have all the people who refused to, who left it blank. They didn't refuse to answer, they simply left it blank, which is a technicality. All right. And then in part C here, I can make a contingency table. The contingency table is where I try and break things down under 2 variables. So now I'm going to compare people's opinions on the death penalty with gun ownership. And this is going to be a contingency table because it's going to tell us all the combinations of owning a gun, favoring the death penalty, not owning a gun, but favoring the death penalty, da 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 da. So if I run this command, we see that in the top in the row here, I've got the first column is favoring the death penalty, second column is opposing it. And then in the rows here, I've got no, doesn't own a gun, refused to answer whether they owned a gun, or yes, they did own a gun, okay? And so what we see here is that 375 people don't own a gun and favor the death penalty. And if I pick on this guy, 59 people own a gun and oppose the death penalty. So that's the contingency table, which sort of breaks down how the population behaves or feels about two separate questions or two separate variables. Okay. All right. And again, when you're doing your homework, I'm not expecting you to have these commands memorized. I'm expecting you to remember that you saw something like it in this file, and you should go grab the commands you need and adjust them for the problem you're working on, right? Okay, so now I'm going to go back to the main video here and stop sharing. Okay. All right, so there's bar charts. Now in section 2.2, we start looking about ways that we can summarize the data numerically. Okay, so numerical summaries. Again, I would encourage you to pause it and copy this material down. Okay, so numerical summaries. In general with data, and oftentimes almost entirely in this course, we're going to be looking and interested in two types of items. What's the center of the data, and how is the data spread? And there's different ways of measuring both the center of the data and how it's spread, right? So here's some of the ways that we can measure the center of the data. Let's begin by assuming that I have a data set is x1 up to xn. So I have n items of a particular variable, okay? And let's assume it's numerical. So these values are all numbers. Well, you're familiar with a lot of these ways of measuring the center. I could take the mean of the data, which is basically adding up all the values and dividing by n. So it's the average or the mean. So it's 1 over n times the summation of the x sub i's. I could also take the median. Now, for the median, I first have to take my data and possibly rearrange it so it's in ascending order from smallest to largest. So I'd rename those y1 through yn. y1 is the smallest, y sub n is the largest. Okay. Now, if I have an odd number of data like 11, the median is going to be the 6th data point. So it's going to be 11 plus 1 divided by 2. So y sub 6 would be the middle data point. Okay. And you know, when I give exams, I'm usually more interested in the median than the mean. Okay. But for other things, maybe the mean is more valuable. If the amount of data I have is even, let's say I have 12 data points, then the median is going to be the average of the 6th and the 7th. Those two are sort of in the middle of the data set. So if n is even, we're going to take the average 1/2 of the sum of the two middle values, y sub n over 2 and y sub n over 2 plus 1. Okay. All right. Now, it's also possible that I want to make sure I'm not giving too much emphasis to outliers. So it might be that I wish to trim off the lowest data values and the highest data values and then take some kind of average of what's in between. This is called a trimmed mean. So for example, I could have a 10% trimmed mean where I'm going to omit the lowest 10% of the data and the highest 10% of the data. So I'm chopping off 10% on either end, and I'm going to take the mean of the remaining middle 80%, okay? Now, if I happen to trim off the bottom 25% and the top 25%, and then take the mean, that 25% trimmed mean is called the mid-mean, okay? All right, so those are ways to measure the center of data. And now let's talk about spread. Okay. Boom. All right, and again, pause it, copy it, I'll come back. All right, so now we're going to talk about how to measure the spread of data. And there's a lot of ways we can do this. And some of these are going to sound a bit confusing now, but we're going to come back to this idea later in the semester. So one thing you can do, and keep in mind, I've got that same data set x1 up to xn. One thing you could do is just calculate the range. Like, how much range is there in this variable? So I could take the largest x value minus the smallest x value. That's the range. Okay? That measures how much the data is spread. I could take something called the interquartile range. So I could take the difference between the top of the third quartile, so that's 75th percentile, the highest data, and subtract it from the top of the first quartile, so the 25th percent of the data. So if I organize my data from smallest to largest and said, all right, median, that's the 50%. The median of the top half, that's the 75%. The median of the bottom half, that's the 25%. I could take that 75% minus the 25% and say that's my interquartile range. Okay. All right. I could also do something called the standard deviation, right? And this is something that you folks are probably familiar with, and we're going to use it a lot. So when I have data that's a sample from a larger population, so let's say I have all the people in the United States, and I sample 10,000 of them somehow. I have a sample of the entire population. For a sample, I can take the sample standard deviation. So let's say I sample n people from the entire population, and I measure some x value about them, their height or their weight or something like that. The sample standard deviation then is taking the difference between the actual data point and the average of all the data points, the mean of all the data points. Take that difference and square to get rid of negative signs. I want everything to be positive here. Sum up all those squares and divide by n minus 1. And you might wonder, why didn't we divide by n? And we'll slowly explain that over the course of the semester. But for sample standard deviation, we're dividing by n minus 1. And then take the square root to eliminate the impact of squaring each of these. So for each of these, I'm taking their difference, each data point's difference from the mean, and squaring it to make it positive, adding those all together, dividing by n minus 1 and square rooting it. That is called the sample standard deviation, and we also generally refer to that as the standard deviation. If I square both sides, s squared is called the sample variance, right? Now, if on the other hand, if instead of taking a sample of a population, if I had the entire population, if I had everyone in the United States, or if I had every male student at St. Thomas, or all undergraduate students at St. Thomas, if I had the entire population in my data set, I could do what you might feel is slightly more natural for the population standard deviation, and take that exact same quantity, but divide it by n instead of n minus 1, okay? So I rarely, and in statistics, we rarely have all the data for the entire population. It's just generally not practical. So if I just have a sample, not the entire population, this population standard deviation exhibits something that we call bias. It's going to be slightly off from what we expect the answer should be. And we generally wish to avoid bias. So population standard deviation generally exhibits bias if we're dealing with a sample, so the entire population. Okay, so that's why we stick with the sample standard deviation in general. Okay? There's also things we could have done, like instead of squaring, I could have taken the absolute value. And that would be another way of measuring the spread. So replace the square with absolute values. That's another way of measuring the spread. And that's called the mean absolute deviation. We could do that. It has some negative things though, so we tend not to. Okay. Now please note, if our sample, our n, is really, really large, then honestly, there's not much difference between dividing by n minus 1 and dividing by n. Like if the amount of data we have is n equals 1 million, dividing by 1 million versus 1,000,001, you're not going to notice it. It's going to be decimals down, decimal places down the line before you see that difference. Okay, so for large samples, these two quantities are pretty much the same. All right, so I'm going to go back to R now. And again, the audio is going to get bad, but what I'm going to do is I'm going to create a set of numbers. And I'm going to calculate some of these quantities, these centers and spreads for the set of numbers. Okay, so again, I'm going to screen share. Chapter 2, 5. We'll go right to the very beginning. Okay. I'm going to look at this first set of commands. So right here on line 10, I have basically defined a vector and I'm calling it x. So x is defined to be, so that's what that arrow means. C stands for vector. Of course it does, why wouldn't it? And the vector contains data. So my data are the numbers 9, 10, 2 copies of 11, 12, 14, 16, 17, 19, 21, 25, 31, 32, 41, and 61. So there's my data. Okay. I'm going to run that so R knows what I mean when I refer to X. And you'll see down here in the bottom left that I'm simply getting a copy of that output. And then I'm going to calculate some of the centers. So the mean is the mean of X. The M is not capitalized. And there it is, 22. The median is median of X. That's line 14. And I get 17. It's the middle value. And then I can do the 25% trimmed mean, the mid-mean, as it were. And that's the command you see on line 16. Okay. So it's the mean of X, comma, the trim off point 0.25. So run it, I get a mid-mean of 18.4 repeating. Now, when I ask it to calculate var and SD, by default, that means the sample variance and the sample standard deviation. That's just what R does. That's the deviation and variance it returns to us. So the variance of X, using the formula I presented on the board, is 204.4286. And the square root of that, or the standard deviation of X, is the SD X command, 14.29. Okay. Right. Now, just a little R trick, but if in the program line you simply highlight everything, you can run all of these lines at once, and all the outputs appear in the bottom left. So you simply have to sort of scroll down to see some of the higher lines as they got evaluated. Okay, so all this should now be in your notes. We're going to be working some problems like this in class when we meet, and I'll also be checking your notes. Okay. You should also have been reading chapter 2, sections 2.1 and 2.2.